If you want to not just work, but actually survive and thrive in a modern fabrication facility, understanding your environment is completely non-negotiable. So, welcome to this explainer. Today, we're diving in and decoding the critical, interconnected layers of the life support system required for your Module 1 Advanced Semiconductor Technician certification. Let's get right into it.
The air and energy inside a semiconductor fab are fundamentally lethal. I know that sounds a bit dramatic, but it's the absolute truth. Our survival inside these massive, high-tech facilities depends entirely on a really rigorous, invisible shield of fail-safe technology. You are constantly surrounded by toxic gases and massive energy sources, and honestly, this shield is the only thing standing between you and a catastrophic event.
Here's our roadmap for today. We're breaking down the 5 essential layers of your protective armor. Number 1, lethal threats. Number 2, armor, which covers gas cabinets and abatement. Number 3, brains versus reflexes, dealing with interlocks. Number 4, taming power, looking at voltage and lasers. And finally, number 5, surviving the subfab.
Okay, starting with Section 1, lethal threats. Let's talk about navigating toxic and hazardous gases.
You are going to see this acronym everywhere, IDLH, but rather than just memorizing it for a test, you really need to understand its true, terrifying reality. It stands for immediately dangerous to life or health. Think of it as literally a 30-minute countdown clock. If you are exposed to a gas at its IDLH limit, you have exactly 30 minutes to escape before severe irreversible impairment hits you. This isn't just a friendly safety suggestion, it's a hard biological limit.
And this breakdown brilliantly illustrates exactly why that countdown clock matters so much. Take arsine, for example. It's a hemolytic poison, and it is fatal at a microscopic 3 parts per million. You won't even see it coming because it's completely colorless. Then you have phosphine, a respiratory toxin that hits you at 50 parts per million. And then there's silane. Notice how it doesn't even have an IDLH limit listed? Well, that's because it's pyrophoric. It explosively self-ignites the very second it touches the air. You literally don't get 30 minutes with silane.
Moving right along to Section 2, armor. This is all about gas cabinets and abatement, or containing and destroying the danger.
So the absolutely crucial point here is how we actually move these incredibly dangerous gases safely. This precise flow path ensures that the massive pressure inside the bulk gas cylinder is safely regulated every step of the way. By the time we hit Step 3, the gas is filtered down to 0.003 micrometers. To put that into perspective for you, that is vastly smaller than a single virus particle. Every single component, from the pneumatic isolation valves down to the purge valves, is strictly controlled before even a single drop of gas is allowed to reach the process tool. What's really fascinating about this setup is how these two systems form a continuous life-saving loop. On one side, you've got toxic gas sensors acting as the alarm, constantly sniffing and monitoring the ambient space right around the cabinets. If they detect even a hint of a leak, they trigger an immediate shutdown. On the flip side, the abatement and exhaust systems step up to safely capture and completely destroy those hazardous byproducts after the gas has been used. It's this beautiful, continuous cycle of monitor, use, and destroy.
All right, on to Section 3, brains versus reflexes. This is all about interlocks, the logic layer of life safety. It really helps to think of hardwired interlocks as pure biological reflexes. These are your Level 1 life safety systems. Imagine someone accidentally opens a high-voltage door. Direct wiring instantly cuts the power in under 100 milliseconds to save a life. There's no software involved, no waiting for a computer to process lines of code. It just happens. Software interlocks, on the other hand, act more like the brain. Using safety PLCs, they process super complex parameters to protect the equipment and, of course, the incredibly expensive wafer from any out-of-spec conditions. When an interlock triggers, the tool abort sequence kicks in entirely on its own, and this happens in the literal blink of an eye. The tool detects the fault, instantly cuts the RF power and gas flows, and vents the chamber to the atmosphere to ensure a completely safe state. The amazing thing is, all of this happens to protect you and the facility before a technician is even notified. The machine autonomously saves itself, and more importantly, it saves you.
Next up is Section 4, taming power. Here we're transitioning from chemical threats to managing massive energy sources, specifically voltage and lasers.
A genuinely terrifying, invisible danger we deal with here is capacitive discharge. You might physically turn the machine off, but energy exceeding 1,000 volts is still just sitting there waiting inside the matching network capacitors. It hangs out there long after shutdown, acting exactly like a loaded spring.
For our safety, we rely entirely on internal bleeder resistors to disarm and drain that massive 1,000-volt trap within about 5 seconds.
Because of all that stored energy we just talked about, lockout, tagout, or LOTO is your ultimate, non-negotiable line of defense. But I really want you to look closely at step 3. Simply slapping a physical padlock on a breaker is not enough. Actively testing and verifying with a meter that an absolute zero energy state remains is the single step that actually saves your life. Bottom line, never trust the lock alone. Always, always trust the meter.
Alongside electrical power, we also have to manage extreme light. While everyday Class 1 lasers, like the ones you'd find in an old DVD player, are perfectly enclosed and perfectly safe, the fab environment relies heavily on Class 4 lasers for things like lithography and wafer marking. These are seriously high power, operating well above 500 milliwatts. They absolutely demand interlocked enclosures and strictly calculated optical density eyewear. Why? Because even a totally indirect reflection from a Class 4 laser can cause instant blindness or ignite a fire on the spot.
Finally, we've reached Section 5, surviving the subfab. Let's look at the hazards lurking just below the main deck. Right below the pristine raised floor of the cleanroom is a chaotic cocktail of extreme hazards. Working down in the subfab forces you to navigate tight confined spaces, deal with blinding heat stress from massive chillers and pumps, and manage potential chemical exposures from exhaust sumps. Not to mention the deafening turbopump noise that sustains at over 85 decibels. Imagine standing right next to a running blender for your entire shift. It's an incredibly demanding environment that requires strict hearing conservation limits and absolute, constant situational awareness.
With all those intense hazards down there, how do we actually survive the subfab? Well, we use the hierarchy of controls. It's really crucial to realize that throwing on a fall harness or a respirator, which is step 5, is technically our very last resort. True safety doesn't start with gear. It begins way up at step 1, by attempting to eliminate or engineer out the danger completely through smart ventilation and subfab layouts long before we ever have to rely on personal protective equipment.
And this brings us right to the core philosophy of Module 1. Ultimately, semiconductor safety is a deeply interconnected web. It is a layered system. A gas leak detection must instantly trigger an interlock, which then isolates the power, while the abatement system kicks into high gear to clean the air. A failure in one single layer must be instantly caught by the next layer to prevent catastrophic harm to you, the equipment, or the incredibly valuable product we're making. So, as you wrap up reviewing this material and prepare to complete your Advanced Semiconductor Technician certification, I really want you to ask yourself a real practical question. The next time you walk out onto that fab floor, which piece of this invisible armor will you be trusting with your life? Think about it. Thanks so much for joining me on this explainer, and stay safe out there.